I'm Stuart from Fab Lab Maker Hub, and this is another in the pop-up Fab Lab series. Today we're going to be asking the question, what is a laser cutter? Well, this is our laser cutter here. It's a desktop CO2 laser. Laser cutters are essentially CNC machines. We've talked about CNC machines in other videos. Essentially it's any machine that has some kind of a cutting or tool head that's controlled by a computer. In our case, the tool head or the cutting head is a laser. Essentially, a laser cutter is unique in as much as it's what's called a non-contact manufacturing. No actual, moving part touches the material, as opposed to something like a CNC router where you have a spinning drill bit that actually plunges down into the material. There's no contact made with the material in a laser cutter. And that's useful because it means you can actually cut more delicate and fine material, things like paper and cloth and leather and things like that you wouldn't necessarily be able to cut with something like a CNC router or a mill. So I'm going to open up the lid here. What's inside the laser cutter? Well, obviously the first thing you need inside the laser cutter is actually a laser. So our laser is in the back here. It's a CO2 laser. Now lasers come in all different types of powers, from a few milliwatts up to a few kilowatts. This laser here is actually a 40-watt laser. I'm just going to move the laser gantry forward here so you can see a bit clearer. The laser tube is this big tube in the back here. It looks like a big kind of fluorescent tube. Essentially, it's filled with CO2 gas, and a high voltage is applied which kind of ignites the molecules inside there, which produces kind of a light which is then amplified backwards and forwards and then shot out of the end and then bounced around a series of mirrors. So there's a mirror down one end and a mirror down the other end, and the laser light gets bounced around until it finally bounces into our laser head here at the top. And there is a mirror here which focuses it down, and there is a focusing lens here which focuses the beam. If anyone has ever taken a magnifying glass on a sunny day and burnt holes in a leaf or a piece of paper, or even tried to set a twig on fire, you'll notice that as you move the magnifying glass in and out, it comes in and out of focus. And there is one kind of point where it's sort of perfectly in focus on the material, on my hand here. The same is true of the laser cutter. We need to focus the laser beam onto our material so that we get the optimum cut, and that's called the focal length. Now, lasers can get very hot, so they need to be cooled down. So for our laser here, it's cooled by water. So there's a tube running into the back of the laser here, and there is basically a vat of kind of antifreeze solution inside the laser here. It's kind of a sealed system, so that it gets circulated through the laser to cool it down and then pumped back in and then pumped back round. So it's a kind of closed system there of kind of antifreeze to cool down the laser as it's cutting. Essentially, laser cutters cut through material by burning through them. And obviously burning anything causes smoke and gas and fumes, and we don't want those fumes to sort of come into the environment, because sometimes they can be kind of toxic or just very smelly. So we need to filter them out. So with our laser cutter here, we have a filtration unit. Essentially this is a big extraction fan that also has inside of it a large filter. So this is kind of similar to the filter you may have like on your vacuum cleaner at home to filter out dust and pollen, but this filters out the smoke and fumes from the laser and effectively scrubs the air, cleans the air, and then pumps the air out of the back, and we usually vent that out of the window. So I'll put that back there. We'll turn the laser cutter back on. Obviously there's big motors inside the laser cutter as well, because being a CNC machine, it needs to move in an X and a Y direction, but it also has a motor here to move the head up and down to adjust that focal length, so it's perfectly in focus. Our laser cutter has one extra feature. Not all laser cutters have this, but quite a lot of the modern laser cutters have started incorporating camera systems into the lid of the laser cutter. What that allows us to do is to see down onto the bed. Now, talking about the bed itself, you'll notice that the pattern of the bed is kind of like a honeycomb. It is called a honeycomb bed. Essentially, as the laser fires through the material, we need something for the parts that we cut to sort of like rest on. Sometimes that's just done on simple kind of pins like that, but a honeycomb bed is really useful because it's the most amount of contact for the least amount of surface area. So essentially the laser will fire down through the holes in the honeycomb bed, and the power gets kind of dissipated as it goes down through it. And then underneath we have what we call a crumb tray. So any small particles fall down through the holes in the honeycomb bed and they're collected in the crumb tray. There's a little bit of wood there. And we can take that out and we can empty that. One of the interesting features that we have on this one is this camera system. So this material here has a QR code on it. And when we put this into the laser cutter, the camera scans the bed and it identifies the material for us. It now has realized that that is 3mm basswood plywood, and it has gone and it's set the correct settings for that particular material for us. The other thing that we can do is the laser cutter has the ability to even work without the computer connected. So if we want to just quickly cut out a shape, say for instance I want to cut out a very simple kind of shape here. I'm just going to draw a triangle with a little kind of notch in it, like that. I can put that in the machine. The software will scan that. Anything that I draw in red will be cut. So if I now just literally just hit the button, I've done nothing with the computer. If I just hit the button, it's going to scan this, recognize that shape, and in a moment it's going to start cutting out that shape for me. So if I have, you know, a very simple design that I want to just cut, I can come, sketch it onto the material and then cut it out. There you go, it's starting now. As you can hear, the fans are starting up to extract the smoke. There's some smoke being generated there. And now that's gone. So we just wait for the smoke to go away, and we can open up the machine and we can take out our, there you go, the fans are coming up now to start extracting more. So there's our part that we've just drawn, and it's cut around the outline of that shape for me. I can take the coating off. There's like a paper coating on the material to stop the burning so much. There's our finished part cut out on the laser cutter. So one of the great things about laser cutting is the kerf. Kerf is something that all cutting machines have. If you think about a saw, just an ordinary hand saw, The kerf is the width of the blade essentially. So when you're cutting into a piece of wood, the gap that's left from the cutting is the kerf. On a laser cutter, because we're using such a focused beam of light to cut, the kerf on our machine here is about 0.1 of a millimeter. It's really, really small. So if you look at the piece here that we've cut out, and you'll notice that it kind of fits back in there. It's almost like a jigsaw piece. There is very little kerf on it. So that is really useful. We can use that to make very tight tolerances. So for instance, we could make a piece that would slot into this piece and fit together really tightly. So being able to have a very small kerf is one of the real big advantages of laser cutting. Like I say, this is a CO2 laser. It cuts wood, plastic, paper, cardboard. It can cut leather, it can cut felt. One thing it can't cut though is metal. CO2 lasers don't have enough power to cut metal. They can engrave metal, but they can't cut metal. And if you need to cut metal, you would require something what's called a fiber laser. Fiber lasers have a much higher power, up in the kind of kilowatt range, and they use a fiber optic cable, similar to the cables that broadband is being provided on now, the fiber optics, to amplify the light to such an extent that it can actually cut through metal. The other thing about laser cutters is essentially you're cutting away material to leave behind, so you get left with essentially sort of, waste material. Laser cutting isn't quite as efficient as, say, 3D printing, where you're building something up from raw material. Essentially you're left with kind of scraps. That's why something like the camera system is good, because it allows you to sort of maybe reuse sort of waste material and place things wherever you can fit them in. So that's always useful. The other thing, as well as being able to cut, is the engraving side of things. Essentially, to cut through something you need a much higher power, but to engrave something you basically ramp the power down, and essentially all that does is just kind of like create like a small cavity in the surface of the material. Now there are other laser cutters as well that are called laser marking machines, and essentially what they do is they would use materials with a special coating on them, and essentially what they do is alter the kind of carbon composition on the surface of the material to create a kind of a mark on them. A few different types of lasers there, and a few different types of laser cutting. As I was saying, laser cutting is one of the most useful tools that we have in the Fab Lab, and it can be used to make lots of different products. So that's a quick intro to laser cutting. Hope that was useful. Thanks for watching.